Okay, we're back. This is the third session associated with this topic, the distributions. Uh, Hopefully by now you sort of figured out, hey, where does this material come from? It is one of those things where we're trying to combine material from several chapters so that you can see how they all fit together. And some of this comes from chapter 4, some from chapter 5. The majority of it probably from 5. But there's also some from 6 and 7, which at this point in the semester is probably going to be a little bit of a preview for you instead of going back over and looking at the information that you've already covered. So again, the whole idea is to try to go through and tie all these things together so that you can sort of see how they fit together. So without any other further comments from me, let's go ahead and look at this.
To the binomial. Now again, we talked about the Poisson as an approximation to the binomial, but we had NP was less than or equal to 10 and N was greater than 100. But when we do this, the normal's approximation, we want NP to be greater than or equal to 5. So we can use the Poisson when the probabilities are really small, and we can use a normal when the probabilities are sort of in the middle there. Again, the binomial calculations can be difficult, and so we want to use some approximation, either the Poisson or the normal. So, bottom line, for the binomial, if n is small, then use the table. N is less than 15, use the table. If n is large, and NP and NQ are greater than 5, then use the normal to approximate the probability. If NP or NQ is small, then we use the Poisson to approximate the probability. So you can see how these sort of fit together. Okay? Now, very important, the central limit theorem. Two different distributions are considered here. And the original distribution and the distribution of the sample means. The sample means tend to be normally distributed. So I've got a box of numbers here. And so I go through and I draw out 6 of those and I calculate a mean. I draw another 6 out of those and I calculate a mean. I draw out another 6 and I calculate a mean. Those means will tend to have a normal distribution. That's what the central limit says. Although I may have in this distribution, I may have 100 ones and 5 twos and 1 3. That means that the original distribution may be something like this. It's not normal. So the original distribution doesn't have to be normal, but it does say that the distribution of the means taken from that are going to be normally distributed. That's the central limit theorem. The sample means tend to be normally distributed. It doesn't matter what the original distribution looks like. Well, there it is. There you can see it again. I read it and it wasn't on the screen. So the sample means tend to be normally distributed. Doesn't matter what the original distribution is. And this is something that's used constantly in statistics. We will calculate the standard error of the mean. That's going to be the standard deviation divided by the square root of the number of the sample means. So let's do one of those. The standard error of the mean. Okay, what is the standard error of the mean? If the standard deviation is 15, the number of means is 25. So we just take 15 divided by the square root of 25, 15 divided by 5, it gives me 3 for the standard error of the mean. Very easy to calculate. The continuity correction, sometimes when we're comparing a discrete random variable to a continuous random variable, or we're trying to approximate it with a continuous random variable, then we need to go through and correct it by 1/2 of the sample size. And this would be x minus 0.5 if the interval size is 1, and x minus 0.5, and x plus 0.5 if it's beyond that. Okay, So let's go back and look at our questions right quick. Which distribution is the mean calculated by NP? Okay, so we should know that's binomial. Consider the histogram of the distributions. Which distribution has a plot that's rectangular? That was the one that looked like this, and that was a uniform. And which distribution is used to approximate the binomial? Well, that's sort of a trick question, isn't it? Because you're going to use the Poisson if NP is less than 10, and you're going to use the normal if NP and NQ is greater than 5. So you can use that to do that. Okay, distributions. Again, maybe a little more technical than you wanted to see, but this is good information, and it helps you to understand some of these concepts, because distributions are very critical to the study of statistics. I hope you have a good day, and
well, as you can tell, sometimes those just end at a time when I'm in the middle of a sentence. Again, hopefully this is, as I said before, is useful stuff to you. If there's something else that needs to be in these videos that you really need an explanation of, certainly communicate that to me. I do want you to learn this material. It is useful. It will help you to make decisions. We're going to find out later on. I mean, I know that right now probably a lot of this just sort of is out here and out there and all over the place. But as we get into the later chapters, chapters 8, we'll show you how all of these start fitting together and allow us to go through and do some very interesting things with statistics that will help us to make decisions and all those kind of things. So we'll end this, and hope that you have a good day.